Hello everyone. Good afternoon for the day two session on wildlife analytics. For our day two session on wildlife analytics, where we had our discussions or introductions and advantages and improvements in wildlife based on analytics yesterday, we'll continue on with the CRISP MLQ methodologies. So the agenda for today would be the stages of analytics, how you identify a problem and how you try to rectify that problem. CRISP MLQ methodologies. What are the methodologies in the CRISP MLQ? We'll be discussing about supervised and unsupervised learning, overfitting and underfitting. What does it mean and how it can be solved? Model evaluation and tuning, data split and error functions. So these are the concepts we'll be discussing today. So stages of analytics. We have 4 stages of analytics when we are dealing with a problem statement. Suppose, let's say, we have data collection. As we're talking about wildlife, let's take an example data that is collected through wildlife through forest camera sensors and jungle sounds. So, what type of data is getting collected and how fast the data is coming in? These are the factors we take into consideration. So, first, we have descriptive analytics. Here, descriptive analytics is telling what has happened. And also, you ask another question, why has this happened? Suppose you have a problem, you encountered a problem. When you are collecting the data from the forest camera sensors and jungle sounds. Okay, this is your type of collection of data, and you are encountering a problem that the data which is collected is not accurate, and the jungle sounds are not getting recorded as you have expected it to be recorded for your analysis. So, first step you proceed with when you have this doubt is you go for descriptive analytics. That is, you ask or you think what went wrong, what has happened for this data to not be collected, and why has this happened. Okay, then your After figuring out these two questions, which you ask yourself, you have some type of idea why this has happened. Next, you go to diagnostic analytics. And here you ask the question why it has happened. Here you have some ideas on why has this happened, and here when you go to diagnostic, you exactly know the problem and you ask why it has happened. Suppose say here the algorithm that we have built to collect the data has not been working accurately. So that is why you're facing the problem that the data is not getting collected as how you require it to collect it. So you have figured out the problem, why it has happened. Why it has happened? Your model is not working up to the mark as how you predicted it would work. So then the next step after you figure it out, you go to predictive analytics. So what happens in predictive analytics is you try to predict. The question that arises here is what will happen? Will you get a large scale disturbances, or it doesn't affect your prediction? It doesn't affect your analysis. Will it affect or will it not affect? You try to predict what will happen if the data is not getting correct. The data collection is not happening correctly. Will that be a problem for me? Okay, you try to ask these type of questions. And then in prescriptive analytics, when you are asking this question in predictive analytics, you realize that yes, it will be a problem because the data collection which will happen is very important for us to do the analysis of any problem statement. So the forest cameras are not collecting the data, or the jungle sound sensors are not collecting the data accurately, then we cannot build a model that gives us results. So next, you go to prescriptive analytics. Prescriptive analytics, here you start thinking what to do. Or you get ideas, or you ask to give ideas to reduce the risk and increase growth. Here, you try to solve the problem. In prescriptive analytics, you ask what to do and what ideas we can implement to reduce the risk and increase growth. Here, increase growth is nothing but increase the accuracy of a model by collecting the data which is required. Okay, these are the stages of analytics. You go in a step-by-step manner where you want to deal with a problem that is encountered. Okay, so we'll be looking at some of the use cases on wildlife where we will try to understand their analytics using the problem statement. So The first problem statement would be identifying illegal sales. Yesterday, most of our introductions were based on the use cases that are very recently occurred and repeatedly occurred. So the first use case or a problem statement which we have taken is to identify illegal sales of elephant ivory and pangolin scales using Twitter data. Okay, this is our first use case. So identifying illegal sales of ivory and pangolin scales using Twitter data. Here, when we come to descriptive analytics, what has happened? Why has this happened? The question to this use case will be, why are pangolin scales and elephant ivory are very much preferred for illegal sales? Okay. Or you can also, there's also another question that arises is, why are elephants and pangolins decreasing in number year by year? Why are they in the verge of going into extinction? Because we already know the answer. To get their ivories and scales, the animal has to be either be dead or they are killing the animals. Yes. So then you go to diagnostic. Why it has happened? Why the animals are in mass extinction? Or why are these animals getting killed? So then you go to predictive analytics. If the poachers or the hunters keep on collecting this ivory and pangolin scales, will the animals go into extinction? Okay, sorry for that. Okay. What will happen if the hunters and poachers keep on killing the animals? Will they go into extinction? So then they realize that there are chances and they go to the fourth stage of analytics, that is prescriptive, where they want to eradicate that problem. So what can be done? What has to be done to reduce the risk for these animals and stop the illegal sales? Okay, so the objective will be to maximize the identification of sellers. Here, they are taking specifically one social media, that would be Twitter. So we have to browse through the Twitter data, giving out the keywords and start collecting data wherever these keywords are in the referred. Keywords are mentioned. So when you start collecting data, the data which you collected can be again cleaned and get an idea where exactly or who is doing the sales of the illegal sales of these. So that is how prescriptive analytics or the series of analytics works for a problem statement, live problem statement. So the constraint would be to minimize the illegal sellings. Objective is to maximize the identification of sellers in the Twitter site, social site, and constraint is to minimize the illegal sellings. So to come up with this objective and constraint, the first problem statement has to be taken into these 4 stages: to analyze the problem and to come up with solutions and its objectives and constraints, to eradicate the risk, and to reduce sales. So this is the first use case. The second use case is to, okay, the second use case is tick distribution. And abundance in livestock. Cattle, livestock or cattle based on season. So here exactly what a tick is. These are tiny micro insects, you can tell, that are in our cattle, cows, buffaloes, etc., etc. It depends, the abundance of them differs from season to season. So here the problem is tick distribution and abundance in livestock or cattle based on season. So this is the problem statement. What has happened and why has this happened? Why are ticks getting, or in the livestock and cattle, why are they distributed in the cattle? Okay, what are the reasons? Is it habitat? Is it habitat wise, or is it their host, or is it their environment, or is it the climatic changes? Why are they adapting to the livestock and cattle? Why are these ticks, adapting to these livestock and cattle? Why are they making that their home? So in diagnostic analysis, you see why it has happened. What are the chances, or what are the ways, or why are the reasons that this has happened? Okay, and for predictive analytics, what will happen if we don't take care of these livestock and cattle? What are there any damage, or there any risks that we have to go through, since livestock and cattle are kind of farming agriculture practices that we do. These livestock and cattle gives us economic balance, so we have to be worried about it. So what will happen if these ticks are getting adapted to these livestock and cattle? Will they pose a danger, or will the cattle and risks, cattle and livestock reduce in number because of these, etc., etc. So in prescriptive analytics, if you find out that these ticks are posing a threat to these livestock and cattle, what to do to reduce the risk of these distribution in livestock and cattle? What measures have you have to take? In each season, the distribution differs. So in the summer season, in the winter, in the rainy season, how are they getting distributed? Suppose in summer season, the count is much lower than in winter season. So why is that? What are the factors that are getting affected for ticks to reduce in number? And in winter, what are the chances or what is the environment that they are adapting to increase in number? These are all the factors that comes into consideration, and you try to solve this problem by getting ideas or experimenting on different solutions to reduce the distribution of ticks in the livestock and cattle. So this is about the second use case. Okay. So now a third use case is the identification of wildlife diseases in Austria from 1980 to 2017. Identification of wildlife diseases. As we know, animals, as though they live in wildlife, we know the ecology or the pyramid of their environment. Despite that, there are some zoonotic diseases that they face. So the researchers have come up a research or started researching on diseases in the year 1980 to 2017 in Austria. They have collected different research papers on the mentions of these type of wildlife diseases between the year 1980 to 2017. Okay, here descriptive analytics. What has happened and why has this happened? They also want to know whether the decline in the wildlife was also a reason for these wildlife diseases. So what they wanted to identify was that they wanted to be sure that these wildlife diseases were also a reason for the decrease in the wildlife. So this is where they got this idea and they researched on it. And once they knew this was also a reason, they went to diagnostic analytics, where they started researching on why this has happened, why it has happened, what were the wildlife diseases that affected wildlife and contributed to their extinction. So, and then in the predictive analytics, they identified in future if there are any more diseases that affects wildlife, what will happen? Will the extinction of these wildlife affects more? Yes. So then the prescriptive analytics, where they were thinking of what to do to reduce the risk of these diseases spreading in wildlife. So these researchers in Austria, they collected the data from 1980s to 2017, and they made a list or the data collection where all the diseases that affected wildlife, and from these diseases that affected wildlife, they taken into consideration again their environment, habitat, type of food they ate to get these diseases, and was it transmitted from one species to other species, etc., etc. And they started predicting, will after 2017, will there be any diseases the wildlife has to face, and that will be contributed into their extinction. So the researchers are still researching on this topic, collecting data to identify the wildlife diseases. This research was only in Austria, but the research is going on all over the world, where researchers are collecting previous data, see why it has happened, what will happen if this prolongs, this continues, and what are the ideas or what has to be done to reduce this risk and how to reduce this from happening, or how to contaminate from happening. Okay. This is about the wildlife diseases. Next is ranking. Risk of animal to human spillover for newly discovered viruses. Ranking here refers to the risk or our immune system degradation. The factors that considered in data collection here are ranking of the viruses, our immune system affectance. As we know, when we had a pandemic of COVID-19, The researchers have mentioned that our immune systems are badly affected because of it. So that is also a main factor when you take that into consideration when we are affected from the viruses that are coming from animals to humans. So here, what has happened, why this has happened? The question again arises when you're dealing with each and every problem statement. Why the viruses have spilled from animal to human? Was it because of the diet we taken, or was it because of the environmental changes that is happening? There are many things that has to be taken into consideration. And why it has happened? What will happen if this keeps on happening? This animal to human spillover, if it keeps on happening, what will happen then? As we know, the pandemic which we recently had, we lost a lot of lives. If that happens again, what are the chances of survival? Next, prescriptive analytics. What has to be done? Ideas to reduce the risk and increase growth. As the latest news says, that the Antarctica melting of ice, permafrost, there are many greenhouse gases and viruses that are getting discovered and released. So, our researchers, as you can see, are what they are now questioning themselves on the prescriptive analytics what to do. So, they are digging up the viruses, identifying them, trying to study them, and build vaccines for them. Yes? So, that is how they found ideas to reduce the risk. As we know through the latest news that are happening every day, that the researchers are going into the Antarcticans and digging up and identifying or researching there for any new virus threats that might come up because of the melting ice. So they already started the prescriptive analytics in terms of, here we are talking about animal to human spillover, but it might be anything. Okay, this is how each and every problem statement goes through the steps of solving a problem and eradicating it. Fifth use case is in an collecting data to infer wildlife behavior on captive animals. As we know, zoos are the biggest enclosed areas where we keep the captive animals. But there are also forest reserves where scientists have an enclosed area where they take animals into captive and collect data to infer their behaviors. Behaviors include their everyday activities: walking, running, eating, sleeping, interacting, aggression, anger, behavior, etc. Behavior comes everything. So if they have, or if they see, or due to climatic changes, they observe any of the changes or evolution that is going on in an wildlife animal, they immediately have to collect the data to study why it has happened, what are the reason, why it has happened, what will happen. Yes, so for that to collect data, researchers take animals into captive and study their behavior. We have a doubt, we might get a doubt here, how captive animals can be studied. If you take a fox, all foxes are same. If you take a cow, all cows are same except for the skin color. Sometimes it differs. But if you take a wolf, or if you take a fox, or if you take any other animal, maybe bear or anything, we can differentiate it by size. But how do you tell this is different from this? No, we can't. So each of these captive animals are given a number. But here we are talking about them wild. Okay, they are wildlife, wild animals. So to collect the data, here drones are used. These drones are equipped with AI analytics where they can identify the animals with their specific numbers through scanners. The drones are designed in such a way they identify the animals with their numbers and differentiate them. And all the information on the numbers are collected into these drones and then sent to the analysis. Okay, so then if there are changes in their behaviors from the behaviors they already had from the previous data they collected, they again go into the analytics, stages of analytics: descriptive, diagnostic, predictive, prescriptive. What has happened? Why did the animal's behavior change from the previous data collection? What are the differences that has happened? And what was the exact reason for this to happen? And then the diagnostic analytics, why it has happened. Predictive, what will happen? If once the behaviors of these animals changed, will it affect other species too? Or will it yes, it will change again. And how would that affect the environment or the ecosystem? Okay, so prescriptive analytics, what to do to reduce the changes, the chance of changing the behaviors. As you can see, these animals that are mentioned here, captive animals, they are not exactly captive. They are just brought into a very large encroachment where they are to study, but they have their freedoms as a forest. So they are basically in the wild, but captivate. After collecting this data, they are again left, and these animals are brought back again after a few years again to study their behavioral changes. So that is how that you can keep track of the new animals, if the animals are reproducing or if the animals are declining. It helps, these numbers helps the researchers to keep track of their species growth or decline. So this is how the stages of analytics helps in wildlife. How a single problem goes through stages for it to be solved and to reduce the risk and increase its growth or accuracy or anything according to the problem state. So here, if you take with this particular problem statement, if you take the objective is to maximize new advancements in wildlife behavior ecology. We have to maximize new advancements. We have to come up with new ideas in wildlife behavior ecology to improve behavioral ecology in wildlife. And constraint is to minimize the lack of knowledge for research. If you did not have a previous year's data, how would you know that the behavioral changes have come in that particular animal? So this helps you to take note of all the changes that are happening every day. Okay, so next is the CRISP MLQ methodology. Model processing. After you identify the problem statement and get to know how to solve that problem, with the data you collected, you go into these model processing 6 phases. Here, let's take an example. If the research has to apply analytics, or the researcher has to apply analytics on the wildlife problem they have encountered or come across with, they should first understand this CRISP MLQ. What exactly is this? As we discussed yesterday, some of the jobs that we data scientists have is data specialists. So if the researchers are unable to understand these problem statements, we come and show them the understandings and results. What exactly CRISP MLQ is? With this, we can build our project easily. First, we need to understand the problem requirements. What are the requirements of the problem? We have to state the problem, its objective and constraint. Constraint here is nothing but the boundary to up to what length it can go. For wildlife, we can set a example requirement as maximum accurate prediction. Constraint as minimum attacks against wildlife, that is poaching, hunting, etc. We can minimize the attacks against wildlife. So this is the business understanding. You define here the problem statement, objective, and its constraint. And next, you have to understand the data. Understand the data. Here, after the data is collected, you doesn't know how your data is. If you have jungle sounds recordings, you want to only identify elephant footsteps and humans who are there to kill those elephants for their avories. But jungle sounds, you have so many sounds of jungle. You have birds, other animals, rustling of leaves due to wind, etc., etc. Rain, yes, water flowing. It depends on the area you have, kept your sensors. So how do you clean this data with all of these only to identify elephant footsteps and humans? So there comes your data understanding. In data understanding, you try to understand the data that in these sensors, I not only have elephant footsteps and humans, but other a huge part of factors too. Okay, so now what you have to do? You have to eliminate these. For that, what do you do is EDA, exploratory data analysis and pre-processing. You first visualize the data, you graph the data and see the distributions of your data. And then you see the distributions of your data. And then after visualizing it and getting to know your data and learning about your data, you have so and so features in it. You go to data preparation. This is basically done. Visualizations, business and data understanding is done by data analysts. And the data preparation is done by data engineers. Okay. So what does these data engineers do? They do feature engineering. They do something called as feature engineering. They are taking further which other inputs. If we have a data set of the problem statement, we have rows and columns. We have rows and columns. And we also have inputs in them. Like, for example, we have footsteps, breeze, wind, sounds. All sounds are mentioned here. Okay, this is just an example. We get rid of unwanted inputs, which can be defined as, if you want data, suppose say this is our jungle sounds, this is a 100% data, okay? But from this, we only want elephant footsteps and human footsteps. So that will constitute of 20% of data. Yes. So for this, you do feature engineering. What does it do? Is it improves the model building. Feature engineering improves the model building. How does improve the model building? Or what exactly feature engineering is doing is it is trying to reduce the input in a way most of the data is retained, but not all of it is retained. As I told you, this jungle sound sensors has 100% data. It is trying to reduce the inputs, all the other inputs as wind, sounds, birds, other animals, water flowing sounds, thunder, etc. etc. There are many you can consider. So this is here, this feature engineering for this particular data set is trying to reduce all of these and trying to retain only the useful data. Not all of the data is eliminated. Here we can say that we are only retaining the data which is useful for us. Okay. So this is about feature engineering. Now you know about the business understanding, that is your problem statement. You understood the data, what your data contains, jungle sounds, and what all it contains. You did your data preparation using the feature engineering. Okay, you cleaned your data, you eliminated what data is not needed, and you took what data is useful for you. That would be these two factors. Now, with the data you collected, you build a model building. Here in model building, you have supervised and unsupervised. That will be just looking into the next slides, what they will have. So you take these two model building, supervised and unsupervised. Depending on your data, you start building the models. After your model building is done, you test. You test and evaluate if the model is working or no. Okay. You are sure that the model is working fine, giving you accuracy. Then you take this model and try to deploy it. Why do you deploy it? Is because the model building and your data will be very huge. So when you deploy it, it doesn't affect your local systems. The factors that considered is your storage, your speed, your processors, so that they don't reduce your so that they don't reduce or they don't reduce the system performance. Okay, so you deploy the model. Deployment can either be in a cloud server or a UI or a web page or all three of them. Okay, and why do we deploy is, as I already told, for our system performance, and also we can't carry a model everywhere. Yes, so that is also a issue. And maintenance and monitoring and maintenance. We have to regularly check through the data that it is performing well. As we know, AI and deep learning and artificial intelligence, and they are improving day by day. There are new technologies coming up. There are new versions coming up. So we have to make sure that the model we have built supports all the versions and it is working accurately. If the versions change, the model building has a chance of not working, collapsing. Okay, there might be some errors in the data, or there might be some errors. If we have worked on already collected data, but suppose if we have a new data coming in every day, every second, so will the model be working fine? So these are the factors that you take into consideration. As you can see here, there are some of the arrows in a green and even in red. So what do they specify? As we learned about how this works, okay, you have your business understanding, problem statement and its objectives and constraints. You have your data understanding. But for your business problem, if the data you got is not comparative, you again go back to your data and business understanding. Was my business problem what I studied was wrong? Is that the reason why my data understanding to the business understanding is different? Suppose you're studying about tick distribution and you got the data of ivory and elephant pangolin scales data, the sales of ivory and pangolin. Is it relatable? No. You have to understand your business understanding and the data has to be understood whether it is related or am I dealing with completely different data. Once you understand that you're dealing with the same data for business and data understandings are done, you then go to preparation, that is feature engineering, EDA pre-processing. You go to understand, you after understanding, you go to preparing the data for your model building. Suppose then after preparing your data, you go to model building. In your model building, if the model gives you good accuracy, then you proceed with testing and evaluation. But if your model doesn't give you good accuracy, you go back to preparing your data. If you have some bias, if you have some variance in your data, it is overfitting or underfitting, you again go back to data preparation and then read through that data, what you have missed, what wrong did you do in data preparing that I am not getting the model accuracy? Why am I getting overfit? Why am I getting underfit? Okay. So by any chance, model building is done with good accuracy. You go to testing and evaluation. In the testing and evaluation phase, you find some errors. Then you have to again go back to business understanding to know that what you're testing and what you're evaluating, the outputs you are getting are related to your business problem, business understanding, or no, or you're getting different results. Suppose, say, you have jungle sound sensors and you want footsteps of humans and animals. You are getting the footsteps of humans, animals, but also birds, sounds. So, how is that accurate? Here, when you're building the model, it has shown that it doesn't have any fittings, underfitting, overfitting, etc. But when you're testing and evaluating, you find out that the model is not that accurate. You have some extra feature added into it. So then again, you go back to business understanding and understand the business problem that you want only these two features. So again, the process begins. You build the model again. And then once the testing and evaluation is done, you get your accuracy, you get your features that you wanted, you go to deploy it. After deployment, you monitor and maintain. But as the years go on or the days go on, your performance of the model is not that good. The maintenance of your model is not happening. So you come back and then deploy it again. And then you start monitoring it so that you don't have any problems that are facing. Okay, these are the data sources. You might have text data, written data, Excel data, sound data, voice data, etc. etc. So this is about your risk MLQ. This is how you, after your 4 stages of analytics, this is the 6th phase of CRISP MLQ. Okay, first of all, CRISP MLQ here is cross-industry standard practice for machine learning with quality assurance. So that is how you build your model. This is a standard procedure that is followed when you have a business problem, when you have your problem statement. Next is your unsupervised learning. First, before we go into supervised or unsupervised, let us understand the difference between supervised, basic difference between supervised and unsupervised. Machine learning, we have 2 types. That would be supervised and unsupervised. Here, X is defined as input variables and y is defined as output variables. For both supervised and unsupervised, they should have inputs and outputs, X and Y. So that we get inputs and outputs. Here, for supervised and unsupervised, we should have X and Y as input variables and output variables. And here for unsupervised, Y is known. You give an input X and the output to Y is already known. But for unsupervised, you give the input X and Y is unknown. Okay, so let's discuss this with an example. These two are the basic differences that we have to keep in mind. Now, let's discuss with an example. We'll take an example which is out of the box. We have a table with customer ID, customer name, state, category, subcategory, and address and PIN code. We take this table and we apply supervised learning in it to it. So we know the output and we are trying to predict that output. Okay. If we have address or a PIN code for this particular customer, one, we have the customer name as Kia, state as Haryana, category as 2, subcategory as 3A. Okay. Category as 2B and address or the PIN code, or let's take PIN code 57308. Fine. Okay. So for this PIN code, or let's say we have address, that will be any street. Okay. We want to find the PIN code. So as we know, if we have the address and the state and the name of the house, the PIN code is very easy to get. Yes. So here PIN code is the Y, that is the output variable, which is very easy to get. So this is the supervised learning model. In unsupervised learning, we do not know the output. So we try to get some probability of what it's likely to happen in the future. So that the difference, so that's the difference between your supervised and your unsupervised. Here, the output Y is known, but in unsupervised, suppose say the pin code is given and they told you to get the address. Is it possible? Most of the times, no. So that is your unsupervised learning. So then you take the probability. You start guessing this might be the address. Okay. So that is how both supervised and unsupervised work. Now, supervised learning model. Data here is stored in the database. Here is some prehistoric data. According to this MLKIF, data understanding and business problem, we take this prehistoric data and we perform EDA and pre-processing. Okay. After we do this, we, as it is an unsupervised learning, we build the model with one of the unsupervised learning algorithms, the machine learning. You select a unsupervised algorithm which are present and you feel which is the best fit for the use case you choose or for the data. Here, output can either be in the form of rules or patterns. We can take these rules and patterns are to be kept, and as you have taken the historic data, now you take a new data which you collected recently. We do the basic EDA and pre-processing as we did for the historic data, and you apply an unsupervised learning model. You take the rules and patterns of the historic data and make predictions, which we got from the historic data, the rules and patterns. We make the predictions from the new data. In machine learning, we don't get exact output. We are always going to make predictions. So this is what we are doing here. Here also, after taking the historical data as rules and patterns, we have a machine learning algorithm and we predict the output. Okay. So based on these predictions, we get some predicted outcomes. Now the unsupervised learning algorithm is completed. Suppose if we have the predictions with an accuracy of 0.68, 0.72, 0.89, 0.90, 0.88, 0.6, 0.78. So here, which has the highest accuracy, that is 0.90, you take it as a best prediction you have got. So this is how unsupervised learning model works. A key thing in unsupervised is y is unknown, and if your y is unknown in your data set, that is how you know you have to use unsupervised learning algorithms for your model problem statement. So this is your unsupervised learning. Next is the supervised learning. Here also we have historical data. Here we take a subset or a small quantity of a historical data. Suppose say we have Austria's data from 1917 to 2017. We take small amount of data that is from 2000 to 2017. That is a subset. Okay. We take a subset, so we take a random sample. Okay. We have a subset, so we take a random sampling of the historical data, because we can't take the whole data, which is very huge, voluminous. Okay. 1970 to 2017, the data would be very huge, but 2000 to 2017, that is 17 years of data, would be manageable. Okay, that is a subset of data. We split this random sample into training and validation. Hence, the training data we are taking here is an ML learning. That is a model. Supervised learning model. We predict the outcome through a supervised learning model with the help of a mathematical equation, that is y is equal to f of x. Here in supervised, we have to remember that y is known. With the help of y, with the help of x, you predict the y. Okay. Here in ML, we either get the output of probability of the event happening or the predictions of the outcome, where the probability of the prediction outcome will either be 0 or 1. Okay. After we have split our data into training data and validation data. So training data, we have taken a MNO model and we have inserted a mathematical equation to it. Now we come to validation data set, where we take the predictions of the training data. Okay, here the predictions of here after implementing the mathematical equation, we get some type of predictions here. Yes. So with the help of these predictions of the training data, and we apply the predictions on the validation data. Here we do something called hyperparameter tuning. We here take our parameter and tune the parameter in such a way that they are improving the accuracy of the model. Okay. Example, if we take the Amazon profits, suppose we get the accuracy by using the regression model y is equal to f of x as 75%, which is not enough. Accuracy we expect it to become. So then we use a hyperparameter tuning here. We recursively go through the loop of training, ML model prediction, validation, prediction. Here we go to the training data, model training, prediction, and we again take the validation prediction and get the validation outcome. Okay, this is the loop we go into till we get our desired accuracy, more higher than this. Okay, this prediction process is called the step 1. Next, in the step 2, predictions on new data. We take the new data and we make a prediction using the mathematical equation again here is f of x, y is equal to f of x to the new data. And we go and get the accuracy of outcomes. So this accuracy is called test accuracy. If the training and test accuracy are both higher, let's say it has 90%, between 85 to 90%, then we say that the model is right fit. When is a model right fit? When training accuracy and test accuracy is between 85 to 90%. Then we tell the model is right fit. If it is not between 85 to 90%, then we have run into some errors that we will see in the coming slides. We will see about what are the errors we can face and why these errors we face. Okay. Here, right fit is errors we face are underfitting and overfitting. And why do we face these underfitting and overfitting errors? Okay. But first, we need to understand, before you go into learning about underfitting and overfitting, you have to know something called as bias and variance. That also we'll see in the next slides, coming slides. Okay. So as we understood here, this is how supervised learning model works. Historical data, a random sample or a small sample is taken from the historical data. That is called a random sampling. And then it is split into training data and validation data. For training data, you build a model, machine learning model, that is supervised learning model. And then you use the equation y is equal to f of x, where you get the predictions of that model. The validation data set, along with the predictions, you do a hyperparameter tuning and you get the model validation outcomes. Okay. This model validation outcomes you keep into consideration and take the new data, and then you do the EDA pre-processing stuff, and then you help of the equation of y equal to mathematical equation, you do the predictions and you always get the predicted outcome. So that is how supervised learning model works. In our next session, we'll look into the problems or the accuracy fits problems we encounter. Why, if a model is not right fit, what are the issues pertaining to it? Why do we get those issues? That is underfitting, overfitting. Okay, and how do you evaluate model evaluation and tuning? How it is done? How model is evaluated and we tune it? Okay, so we have learned today about the business and data understanding. How do you understand the business problem? What leads to you to say that you have a problem statement encountered and you understand the data which you collected and you prepare the data for your model building. Okay, so we have seen or discussed the topics till here. In the next session, we'll talk about model evaluation. What problems do we face while building the model if it is not a right fit? And then we will see about the deployment and monitoring and maintenance. Model evaluation, and we have something called as model split evaluation and tuning. And then we have error functions, confusion matrix, error functions. Okay. So in in next session, we'll be discussing about these topics. Thank you. Have a good day.